Hello guys, welcome back to Maths on African Motifs. Still working on the depth of the center of fluid pressure. We want to see how typical questions might be given. I explained that this basic that you need is the one that you're going to use in each and every question. It's just a repetition that you see each and every question, only that you need to know different types of questions that you might be given and how to interpret the question, right? But the question is always the same. At the end, you need to calculate the depth of center of pressure, all right? That's it. That's what you want. So we need the first area moment and also the second area moment. So you'll be given information like this part that you're given here. Calculate, I will give you sort of the cross section of a water tank. All right, this is a water tank, is in the form of a trapezium. Right, so we have got a water tank that is in the form of a trapezium. Right, let us read the information properly. Okay, remember a trapezium can be this way. That's a trapezium. A trapezium can be this way. We can have the bigger side on top like this. It's a trapezium. We can have a trapezium like this. So we want to know the shape that you're given. It's a trapezium, but how are we going to construct our trapezium? So the bottom of the tank is 3 meters wide. The top 4 meters wide. Okay, this is our tank. The one, remember our tank, is the one that is a trapezium. Be careful. The tank is the one that is a trapezium. So we're given the properties now of a trapezium now. The top of this trapezium is 3 meters. I mean, the bottom is 3 meters wide. The top 4 meters. So the top is the bigger one, as we can see. The top is the one that is bigger compared to the what? To the bottom. So the top, just a sketch like this. I'm focusing on the trapezium, not like how it's going to be like a finally on the diagram, just a trapezium, okay? So this is something of this nature. We just want to have the top like this. The top is 4 meters, which is the one that is bigger here. The bottom is 3 meters wide. So the bottom here is 3 meters. Okay, I'm going to explain this later on. So then we're given, and the height of the tank, which is what? Which is our trapezium. The height of the tank is the one that we're talking about there. The tank, which is what? The trapezium, this one. So it is what? 4 meters. So this is what we have, the height of the tank, meaning to say the tank here, it is 4 meters. That is the perpendicular height. Okay. You have now the idea of what? Of the question. On this part, this one, the purpose of this question is because of this part. That is the purpose of this question. I could have done another question on trapezium just to for you, but for this one, I had to make this because of this one. So I want you to be clear there because you misunderstand something here. This is the height of the tank. Please, guys, understand me. This is our tank, okay? This one. That's our tank, which is in the form of a trapezium. Remember the sides of a trapezium, they're parallel, this and that, we don't care about that. But this is what we have on a trapezium. I hope you're together here. Okay, now let's move on. Now they are saying, the trapezium is there, we talked about it, it's done, which is a water tank. So the tank is full of water. The tank is full of water. All right. Which means that if our tank is full of water, how are we going to immerse it into the canal? How are we going to put it? Because it is full of water. Okay, there are two ways, because this is the part that I want you to understand. In your presentation, as you are taking, as for me, like I said, I'm going to take my water level, which is the water surface, as my x-axis. it means I'm going to have something of this nature. All right, that's my x-axis, which is my water surface or water level in this case. All right. So I've got the water surface. So having this full of water, we are going to put it direct on the water surface. Okay, let me put it this way. You understand me. This is our trapezium on top. It's full of water. So it is going to be like this on top. It is going to be direct on top of the water surface. Okay? It's going to be on the water surface direct. Okay? Being 0, -1, -2, up to -4, because the height of this tank is 4 meters. So it means we also have the 4 meters going down of the canal because it is full of water. So our canal is also ending there. Okay. This is it. Let me put it this. They can ask you, or they can give us this way. Okay. We have immersed our water tank into a canal, but the canal is 6 meters deep. Canal is 6 meters deep. What does it mean? If our canal is 6 meters deep, it means this water tank, as it is immersed in this canal, which is 6 meters deep, it is going down, 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 and it is going to reach 6 meters at a -6 somewhere there. That is where it is going to reach, at -6. I want you to understand this. Okay? This is the canal, this one. The canal is 6 meters deep, not the water tank, but the canal where you immerse, where you put the tank. You put a tank, you immerse it in a canal. Okay, you put it in a canal. The canal is the one that is 6 meters. Okay, this is the height of the canal. But our tank is 4 meters high. So what does it mean? It means we are going up 1, 2, 3, up to 4 units, which is the height of the tank. It must end at a certain point, where if you get up 4, it's going to add a 4. It will be at -2. So it will be like this. This is where your tank was supposed to be, like at -2. It was going to start at -2. So because its height is 4 meters, but we are given that the canal is 6 meters deep. So as you put it down, it is going to reach the level, the ground level of what? Of the canal. But it won't be able to reach the water surface. Why? Because the canal is 6 meters deep. So this tank is going to be covered. Yes, it will be full of water, which is fine. But the tank is going to be covered at what? At -2, up to -6. That is where you are taking the height of the tank, which is your 4 meters in between this one. But this one is of the canal. But here we are not given about that because it's full of water. So we're just going to take it at what? At -4, direct as it is. So this question like this is the same question that they'll ask you that, or they'll tell you that the tank is 2 meters below the water level, or 2 meters below the water surface. They can give it direct like that, or they can give it disguised like that, like this one. They will give you the height of the canal, the depth of the canal, the height of the trapezium, different. So from there, you have to make your mathematical calculations to make sense, right? Because you are immersing something down. So you put it in that way. If it is down, what is the space that is going to be left for it to reach the water surface? Because as it is going to be down here, but it is going to leave a certain space because the depth of the canal is 6 meters, but our tank is 4 meters high. So it is going to cover only 4 meters. There is a remainder that is there for it to reach the water surface. You see the difference there? I just hope someone understands this. If not, I just hope you're going to have another question different from this, maybe, which explains. So it is important that you can just have a sketch of the shape that you have to draw before you put it here. All right. So this is 4 meters, and this y-axis, it divides. It is symmetrical. It is our perpendicular height. it divides our trapezium into 2 equal parts. So if this is 4 meters, we are going to have 2 meters, 2 meters. If this is 3 meters, it is going to be divided by 2. 3 divided by 2 is going to be 3/2 or 1,5. So we are going to have 1,5 this side, 1,5 this side, because it is 3 meters this side. So you divide by 2 because the y-axis is the line of what? Of symmetry. It divides your shape into 2 equal parts. All right. So as it divides your shape into 2 equal parts, meaning to say the area of this side is the same as the area of that side. That's why I explained in the previous case that you'll be having 2 areas. That's why the formula for area, it changes to the normal formula that we are used to, because there are 2 areas that are the same. So it's either you're going to work with this side or you are going to work with this side. So as for me, I'm going to choose the positive side. So at this point, the point here, as we can see, the distance from 0, this is 0 here at the origin. From 0 to here, it's 2 units. So meaning to say x at this point, it's what? It's 2. But in the x-axis, y is equal to 0. So the point there is 2, 0. We can take advantage of this point because this is a horizontal line. And along this x is 1,5, which is same as what? 1,5 is same as 3/2 as a fraction. And the y value where the tank is 4 meters deep, which means the height here is going to be at -4. So that is the point that you can take. Why do we take the points? Remember, we need to calculate the relation between the variables x and y later on, which I explained that you have to find this in terms of what? In terms of y, x in terms of y. And also don't forget to put your representative strip, all right? And also the distance that you're going to talk about, which is the y distance in this case, all right? That is the distance from what? From the x-axis. That's the y distance that you're going to talk about. So that is it for the first part. But not only this, because they also need us to have the relationship, but for the diagram, it's enough. Like I said, I'm going to draw this below the water surface like that. So calculate the relation between the variables x and y, because of what we know later on, that we're going to calculate the area moment, and the area moment is about x. So it needs us to find an expression of x in terms of y. So we're going to have a relationship that can be found on our line in terms of x and y. So you can take advantage of this line. You could have used this side, but that side, it means your points now, they're on the negative. So remember, it is symmetrical. So this will be at -2, 0 if you want to take this side, and this will be at a negative side, 1,5, but on the negative. So it will be -3/2 as a fraction at what? At -4. So that is it. So I'm just going to work with this side. This is what we are used to, guys. We've been working with this side. So I do not want to bring any confusion in our understanding. So that's it. To find the relationship, since this is a straight line, this one, we can take advantage of that. Find the equation of a straight line. Y is equal to mx plus c, where m is the gradient. That means the change in y over the change in x. So m is equal to the change in y, that is, you subtract the y values together, -4 minus 0 over the change in x, you subtract the x values together. From this point to this point, since we used first like this way, y values, we took the y from this point. So you maintain the same order, x also, that point to the other point. So it's going to be 3/2. -2. So do not mix up your points on that case. Do not mix up your points. So this will give us a +8. Okay, that's our m. So y is equal to m, which is 8x. So that's 8x plus c. In order for us to have the value of c, we can take any point that you're given from these 2 points. Since we do not have the y-intercept, we have got the x-intercept in that case. All right, so you can just substitute any point. Okay, you can take advantage of this point 2, 0. If x is 2, y is 0. So we've got a point there, y is 0. So in place of y, we are going to have a 0, where x is what? 2. So that is going to be 8 times 2 plus c, which is 16. Take it to the other side. That's -16 is equal to c. So that's it. We can formulate our equation, guys. Y is equal to mx plus c, and we've got here, we determined the first part. So therefore, y is equal to 8x. So we've got 8x there plus c. Our c is a negative 16. So that's plus and minus, which is going to be a negative. That's it. We can make x to be the subject. Like I say, the relation that you're going to have since here, we have got our representative strip in terms of y, and we have to make our integrals in terms of y. So you're going to make x to be the subject. I explained this previously, guys. So make sure that you watch other videos for more. Y plus 16 is equal to 8x. All right, we transpose this, then we're going to divide by 8. Let us just divide each and every term by 8 so that we do not have confusion. Or we can, it's fine like that, okay? So that we do not have confusion. We could have just divided everything by 1/8. We take it out as a fraction. Still, it's fine. Just leave it like that. So x is equal to y/8. There's nothing that we can do there. Let's just write as y/8 plus 16 divided by 8. This is going to give us a 2. So that's x is equal to y/8 plus 2. That's our relationship. All right. So I'm just going to take this relationship because I want to use this space. I'm just going to write this. So we found that x is equal to y/8. So we got y/8 plus 2. Right? That's y/8 plus 2. That was our relationship from our calculations, right? That is what we got. So with this information that we have, the question further on says that we need to determine on 5.42, calculate the area moment. When it is just area moment, is the first area moment. Second area moment, they state it second. At first area moment, they don't state, they just calculate area moment, all right? Of a vertical end of the tank about the water level, meaning to say according to the condition that you are given before here. So that one, do not worry, just take it from your diagram. As you can see from our diagram, everything is there. We can interpret from there. All right, so this was our 5.41. All right, now we need 5.42. Okay, so let us just remove this part. Like I said, I'm going to need to make some further calculations, and I need to ask to have the diagram closer to our calculations so that we can understand this. All right. If you were to continue and later on observe here, you will see that later on they need us to calculate the depth of the center of pressure, which is the one that you're given its formula. Even the formula for the first area moment, we have it from our formula sheet. All right, we know that the first area moment, this is about the x because we're taking our distance from the x-axis, and it states that the first area moment is simply r, the integral of dA, all right, which is taken from a to b. These are the limits that we are given there. Like I said, it's supposed to be c and d, but you can use a and b as you only understand. And also this being the distance that you're taking, remember, from our centroids, right? We are talking about the distance that we take from what? From the x-axis, which is y in this case. So this will be the integral of a to b of y times dA. This is where most confusion comes because our dA, we are used to that area concept. dA is equal to x dy. So therefore, our area is equal to the integral of x dy with the limits a and b. But you'll be surprised now to say our dA is 2xy because there are two areas, like I was mentioning. This area and this area are the same. This region that we have and this region are the same because this is symmetrical about the y-axis. That's why I said you could have used this side, but we decided to only work with one side. So this side that we are working with, this one, is the one that you're obtaining the answer for the area like this. But there are two of them because we calculate this, you calculate the other side, you get areas. You're talking about the magnitude of area. It will be the same. The magnitude of area will be the same. So that's why we have to multiply our area times 2. So our dA is going to be 2xy because there are two areas which are the same. So that is the presentation of a dA. It's area times 2. There are two areas there. That's why we multiply this by 2x. It's not like a formality to say 2x. No. So it's from this concept. But if you understand that, then always you have to write like that. So if I explain, guys, this is the formula, it will be one, where is it taken from? All right, I hope now you understand. And like I said, you have to please join the membership by clicking the N6 Studies membership. You will be able to have unlimited learning up to the writing of exams. And also you'll be able to ask any question of your choice that you want. Okay, that's as long as it's part of N6 mathematics. Let's move on. Like I say, you can even factor out these two. It's up to you. The simplification there later on, it's up to you. All right. So I can just factor out the two. I remain with the integral of, now I'm going to put the limits A and B. These are the limits from 0 to -4. So that's from 0 to -4. Y is not going to change because we are integrating with respect to Y. So Y is going to remain as it is. But this X is supposed to be removed because our integral is supposed to be of Y. So we are going to replace our X with the expression, for X. This is our expression for X. That's why I said you have to make X the subject. You have to make X the subject of the formula. So that's Y over 8 plus 2. So you're going to substitute this as Y over 8 plus 2. Just like that, you're done. So that's it. Guys, just like that, like you're done. The rest is your normal integrals. What is it that you need here? You need to integrate. So what can we do? Expand the brackets, then integrate. We are done, right? So let us integrate. So that's 2. The integral of 0 to -4. Y times Y there is going to give us Y squared. So that's Y squared over 8. Y times 2, that is just going to be 2Y like this. All right, so let's integrate this with respect to Y. Then we substitute our limits. So if we integrate, that will be, remember integrals, we add 1 on our exponents. So it's Y to the exponent of 3 over, so it's supposed to be like this, Y to the exponent of 3 over 3, but already there's an 8 which is there. So you multiply that. So that's 8 times 3, which is what? 24. So this will be a 24. Then for 2Y, this is already a 1. You add a 1. So 1 plus 1, it will be a 2. So it was supposed to be like this. 2 Y to the exponent of 2 over 2. And the 2 and the 2 was going to cancel. So you remain with Y squared. So that's plus Y squared in simplest form. And from there, our limits taken from what? From 0 to -4. That's from 0 to -4. That's it. You have integrated, so you just have to substitute the limits. That's your area moment. Interpretation of this is important. It's very, very important. From there, it's just your normal integrals. As you can see, this is just our normal integrals. And after you've integrated, we can substitute our upper limit minus lower limit concept. So our upper limit, which is a 0 in this case, but just may looking, guys, that's a 0 here, a 0 there. So you're going to get a 0 on the first part. That's a 0 there. Minus the lower limit taken at an x being -4. So that's -4 to the exponent of 3 over 24 like this, plus in place of y, that's -4 to the exponent of 2. All right, that's our lower limit. So you're going to substitute like this. All right, so that's it. We just have to simplify properly to get the final answer. But in our normal simplification, as I said, this is just going to be a 0 there. So it's going to be minus. This answer, that side was going to give us 40 over 3. So if you simplify this, it will be 2 times -40 over 3. If you check it properly, then that will give us a -80. That's -80 over 3 cubic units, or you can write it as a decimal, -26,6667, and so on. Cubic units, but these are meters, so you can write properly cubic meters because already we are given this in terms of meters. Remember, they properly gave us here. This is 4 meters. So instead of us writing cubic units, you can write cubic what? Meters. And as I say, the negative there is an indication because we drew our diagram below. Remember, this diagram can also be drawn above the x-axis. It's up to you on that presentation on how do you want your diagram to be. So it's best that you follow this one because we've been talking about this a long time. All right, anyways, that was the whole idea of the question. Then on 5.43, now they are asking us to calculate the depth of the center of pressure on the vertical end, which is from the one that we had before our first area moment of the tank. If the second moment of area is given, we are given there, but this is second area moment, which is 69,333. These are meters to the exponent of 4, not cubic meters. This is meters to the exponent of 4. Since they gave us this one as a decimal, let us just write also our answer here as a decimal so that it can make sense. All right. So that this can make sense. I'm not saying if you use this like this, it's wrong. No. All right. It's not wrong. It's just one and the same thing. All right. But just because we are given there as a decimal, so this is our first area moment. That's our area moment with respect to X, which is our first. All right. So remember from our formula sheet that the depth of center of pressure, which is the one that we are supposed to calculate, is given as the second area moment. So that's your second area moment over the first. But from the formula sheet, they gave you like this, the integral of r squared dA from A to B like this. If you check your page 6, it must be page 6 or page 5. But you check on the center of pressure, you're given a formula like this. This is first area moment over the second area moment. That is what they're simply saying. So we are given the second area moment. We are not calculating this. We are already given that this is what? 69,339. Sometimes they give you the first, they ask you to calculate the second one, then the center of pressure. Here we are given the second. It's an advantage. All right. So you just have to substitute 69,333. So this is 69,333 meters to the exponent of 4 over our first area moment, which is the one that we calculated this formula. As you can check, this is the one that we used, this formula. That is the one corresponding to this formula also. And we got our answer is negative 26,667. So we're just going to divide negative 26,667 cubic meters. So this will give us the depth of center of pressure. That's how we can calculate this. And that was going to give us negative 2,600 like that. Negative 2,600 like that meters to 3 decimal places. If we are to round off to 3 decimal places, this will cancel and you get meters. So that is how you play around with this question. All right. So I just want you guys to revise as much questions as you can. Work with your question papers. If there is a question from any question paper that you have worked on this topic, let me know about this. Let me know about that question, right? Maybe it is having a challenge. I don't know. What type of question is it that you have? Let us know. So join membership. Don't forget about that so that you'll be able to have as unlimited access to these videos because you'll be able to ask any question of your choice, right? Then also introduction of topics they are there. So guys, this is a platform that is unlimited to us until your exams. You have your own distinction. That's a promise that I give to you at this channel. It's a promise. In mathematics, that's a distinction for you. I'm not saying anything out of anything or out of what. It's a promise that I'm saying. Promising you this, I'm promising you this. It's like that. All right. So anyways, guys, till we meet again. Till we meet again.